Hello, in this video, we are going to find the exact value of each of the given trig identity using the double identity. Let's just review the trig identity really quick. So these are the double angle identity. So sine of 2x is 2 times sine x cosine x. These are the identity that we are going to use for this example. So I'm going to go ahead and begin. So we know that sine 2x or sine 2 theta equal 2 times sine theta times cosine theta. Okay. Now the next step, we are going to substitute what we know here. So we know that, let me write sine 2 theta. Okay, so we know that cosine theta is given, except sine theta we don't know, but cosine theta we do know. So I'm going to go ahead and write down the cosine theta first. So cosine theta is negative 5 over 13. And we are looking at quadrant number 3. Okay, so this is quadrant number 3. So I'm go ahead and sketch it really quick here. Okay, so this is 0, pi over 2, which is 90 degrees, pi, 180 degrees, 3 pi over 2, 270 degrees, and go back to 2 pi. So let me go counterclockwise. Okay, so our angle is in quadrant number 3. Okay, so I'm just go ahead and just get our angle theta. So you think about this is our angle theta here, and I'm talking about if I'm looking at the reference angle. Okay, so I'm just look at the reference angle, only this acute angle. Okay. So since we given cosine is negative 5 over 13, so I'm going to go back here and I'm going to go ahead and construct a right triangle. So this is our reference angle now. So go ahead and label what we know here. So cosine is adjacent over hypotenuse. So the adjacent is negative 5. The hypotenuse is 13. So we don't know the opposite. Okay. So but first of all, we keep in mind that we are in quadrant number 3. So sine have to be negative also, because in quadrant number 3, only tangent and cotangent will be positive. So now the next step, we are going to use the Pythagorean Theorem. So we will have y squared plus negative 5 squared equal 13 squared. So be 5 squared plus 25 equal 169. Then we go ahead and subtract 25 from both sides of the equation. So that will give us y squared equal 144. Take square root both sides. And we're talking about the length. So we have to be positive number. So y equal 12 here. But since we are in quadrant number 3 and we are talking about sine. Okay. So think about sine of the angle theta is opposite over hypotenuse. Okay. But since we are in quadrant number 3, so I'm going to put the negative sign. So this can be negative 12 over, I'm going to use different color here. over 13. So now that's it. We are done. So go ahead and multiply these three fractions. So again, if you don't see the denominator, by default it'd be 1. So that will give us 120. 2 times negative 12 times negative 5, that gives us positive 120 over 169. Okay, so that would be our answer. Let's look at the next example. Here in this example, we want to find the exact value of 165. So we know that 165 is not a special angle. So we have to write 165 either at the sum or the differences. I'm going to go ahead and use the sum. So we write at 120, at the sum of 120 and 45. So now we have to remind you again, if you remember the sum of cosine A plus B is cosine A cosine B minus sine A sine B. So now I'm going to go ahead and apply the sum formulas for cosine. So that will give us cosine of 120 times cosine 45 minus sine 120 times sine of 45. So now I'm going to go ahead and substitute cosine 120, cosine 45, sine 120, and sine 45. So let's start with cosine 120. That would be negative 1/2. Cosine of 45 be square root of 2 over 2. Sine 120 be square root of 3 over 2. And sine 45 be square root of 2 over 2. So now go ahead and multiply first before we subtract. So multiply, so that gives us negative square root of 2 over 4. And again, multiply the two fractions. That gives us negative square root of 6. So when you multiply the two square root or the two radical, you just multiply the number inside the square root. So 3 times 2 is 6. Divide by 4. So now two fractions with same denominator. We go ahead and subtract the numerator. Okay, that's it. We are done. And thank you so much for watching. Goodbye.